I am Mr. Arbach. I will be your video science teacher today. I'm holding before me a molecule called glycerol, or at least something kind of like it. We call it glycerol. Why? Because it's got these OH groups on it, right? That makes it an alcohol. There's a little more to it than this, but it's 3 carbons, and it's the backbone of a polymer that we're going to make called a fat. And in order to have a fat, you have to have a monomer of fat. And I have one right here. It's called a fatty acid. And this is an unsaturated, or excuse me, this is a saturated fatty acid. And what that means is every single one of these carbons has single bonds to it, saturated, full of hydrogens is what you want to think of. No, that's not a joke, that's true, it's full. It can't take any more, it's saturated. And this is an unsaturated fatty acid. They can both be in the fat. It's unsaturated because these double bonds say it's not full of hydrogens like this one is, because when you're double bonded to another carbon, those bonds could be to other 2 hydrogens instead, but they're not. Notice how the fatty acid that's unsaturated is a little squiggly, whereas the one that is saturated is not as squiggly. It's more of a straight line than this one anyway. And what I'm going to do is I'm going to make a polymer. And just like all of our other polymerizations, it happens with the dehydration synthesis reaction. Remember, we make water. In this case, we're going to make water with the hydrogen from the fatty acid and the OH from the glycerol. That pops off. The hydrogen pops off. What do they make? Water. Condensation reaction. And that means that this oxygen now has an extra bond to make that it needs, and this carbon now has an extra bond to make that's freed up by the dehydration, and so they attach to each other. And this is how we make a fat. Let me get more of the saturated ones. Let me see your saturated fat. Thank you. Thank you. Who knew fat could be so beautiful? Look at that. Okay. And it's the, what did I say? It's the OH from this, and the hydrogen from this. And whoops. We'll edit this part out, where I appear to not know what the heck I'm doing. There we go. Dehydration. And another one. And you need one more. Okay. And, okay, so, and we have one more, and we'll do this, and now we have a lovely triglyceride. It's a standard type of fat, and the thing about it is this is a saturated fat because all of the fatty acids are saturated. This is bad for you. This is what gets in your heart and clogs it up because all of these sort of stick together, and they stick to other ones and stick to other ones and stick to other ones, and it can clog up your system. And so instead, what you want to have in your diet is you want to have unsaturated fats, because, let me get some more unsaturated fat here. You guys have an unsaturated fat. Here we go. Another dehydration. See, these, look at these, look at that. Now, I know you don't necessarily see the difference, but I do, because, somebody fix that while I'm talking, please. Tech group, nothing is happening here. Anyway, thank you. Thanks for mopping up the water there, David. See, these unsaturated fats are more squiggly. They're curly-cued. They turn corners. They don't all line up in straight lines, and they don't stick to each other the same way. Because look how they're all irregular, and it's okay. They're all irregular, and this actually is true in your body. Unsaturated fats come from oils like vegetable oil, but unsaturated fats don't clog up your system. See, these are a liquid at room temperature. Saturated fats, because they stick to each other in big clumps. Saturated fats like butter and cheese and all that, they're a solid at room temperature. these are an oil, or these are a liquid at room temperature because they don't stick to each other. So there you go, the difference between saturated and unsaturated fats.